Welcome to the Math Record. Today I'll be covering the second part of the ICTM Regional 2018 Division AA Precalculus, where I'll be answering questions 17 and 20. So let's start with 17. P of x and q of x be quadratic polynomial functions with integral coefficients such that p of 1 equals q of 3. And then there's a bunch of other points, so I'm going to put them down because sometimes it's just kind of hard to read it from left to right. Up to down makes more sense because you could compare. So P of 1 to Q of 3, and then P of 2 is equal to Q of 4, okay? And P of 3 is equal to Q of 5, and P of 4 is equal to Q of 6, and P of 5 is equal to, so P of 5 is equal to Q of 7 plus K, where K is a multiple of 23. Okay, determine the smallest value of K. So what I notice is that from P of 1, 2, 3, 4, they're increasing by 1. It's also Q of 3, 4, 5, 6 also increase by 1. And they're always going to be from 1 to 3, that's a 2, 2 to 4, that's a 2, 3 to 5, that's a 2, and 4 to 6 is a 2. So for these four equations, we know that the general equation is that P of x is equal to Q of x plus 2. Right? Because you plug in 1, that's P of 1 equals 3 equals Q of 3. Plug in 2, P of 2 equals Q of 4, right? So it works on all four of these points. So what does this tell us? Well, this doesn't really tell us anything because we plug in 5 in here. That means P of 5 equals Q of 7. But K is a multiple of 23, so that doesn't really tell us anything. So what we could do is that we could subtract them by each other because usually for equations, we like to get it equal to 0. Okay, so So does this 0 tell us anything? Well, not really. We just rewrote this equation to make it equal to 0. So that doesn't really help us with anything. But the key word in number 17 is that they ask us a quadratic polynomial functions. And we're working with polynomial functions, let's say f of x. We usually like to set the polynomial equal to 0. And so then we can find out all the roots. So we're going to do the same thing for this. So we have f of x is equal to p of x minus q of x over 2. So p of x, p of x minus q of x plus 2, right? So we know that this is true. So kind of number. So we know this is always going to be equal to 0 for the first 4 points. So and usually for a polynomial, there's a coefficient. So let's call this coefficient a. Um, because I usually just like to use a. So it doesn't matter what variable you put in front. And then just don't use k because they're already using k here. So what we do now is that we could plug in a value for our x. So we already know 1, 2, 3, and 4 because if we plug in 1, right, that's p of 1 and then q of 3, that makes 0. If we plug in p of 2, that's p of 2 minus q of 4, that's 0, right? And you do it for 3 and do it for 4, you find out that those 4 equals 0. Remember what this says? This is a quadratic polynomial function. So if this is a quadratic polynomial and quadratic polynomial, those two make a quadratic polynomial, right? Because that's the highest one it could go. So if you plug in 1, 2, 3, and 4 into here, and it equals 0, then all of x of 1, x equals 2, x equals 3, x equals 4 is a root for x of f of x because it's equaling 0. That's just the idea of a polynomial. So that means f of x is equal to some kind of coefficient a times x minus 1, x minus 2, x minus 3, and x minus 4. So because if you plug in 1 here, that's equal to 0. Same thing as when we put in here. Plug in 1, 2, 3, 4, right? So now we could plug in uh, f of 5 in here because we're plugging x equals 5. So when we plug in a 5, that's a times 4 times 3 times 2 times 1. So f of 5 equals, that's 12, 24, so it's 24a. So that tells me that when we're looking at this question, we have p of 5 minus q of 7, which is basically what f of 5 is, equals, so then we know that this value is also equal to our k, because that's how we've rewritten it, and k is a multiple of 23. So multiple of 23. But we look at this value, which is f of 5, which is this, which is also equal to our k. This is a multiple of 24. So what is the smallest value that we could choose for k such that it's a multiple of 23 and a multiple of 24? Well, that would be if it's 23 times 24. That's the smallest multiple because that's your least common multiple. So 23 times 24, that will give you an answer of 552. And that is your answer for number 17. So it just takes a little bit of logic. So for these type of questions, you just had to think about it. Okay, number 20. A plane flying at a average speed of 420 miles per hour at an angle of 40 degrees west of due north encounters a wind pushing 20 miles per hour at an angle of 20 degrees west of due south. So let's make our coordinate plane. So how it works is that it's north, east, south, and west, right? So for our 4 points. And then when they're saying they're moving at a 40 degrees west due north, so north, and then you go 40 degrees west. So it goes this way. And then we have 420 miles per hour. So I like to put that at the tip. So then we know how much it's moving at. So this is your 40 degrees, but I usually don't like to put it here because I like to put it in respect to the x-axis. So 90 minus 40, so this is 50 degrees. Okay, and then it encounters a wind that's going 20 miles per hour at an angle of 20 west south. So then south and then west, so it goes this way. So something like this. And it's going at 20 miles per hour. And this is 20 degrees. So I don't like to use this, so let's put this as 70, because 70 plus 20 equals 90, so it's the same degree measure. So when we're looking at this, when we have a plane, now it's going to be traveling at a new angle, is north. So since it's there's a wind that's pushing it, that means instead of moving just this way, it's going to move a little bit smaller, right? So something like that, and it's moving at a new angle. So they're asking what would that angle be? Well, this angle, because they're asking for west due north. So it's this. So we need to find this angle, subtract it from 90 to get this angle. So let's try to do that. So let's break down this 420 into its x and y's. So right triangle, right triangle, right? So then our x component would be 420 cosine of 50, and its y component is 420 sine of 50. What's the x component for this one? Well, this is 20 times sine of 70. So plus 20 sine of, 20 cosine of 70, sorry. And for its y component, it's actually negative because it's going down. It has to have minus 20 sine of 70. So this is x and this is his y. So then now we could just calculate it in your calculator. And then when we divide the two numbers, that would just make us our new triangle. So this is going to be our new y. This could become our new x. When we divide them, we get some kind of ratio. And then we'll get this angle, which we could call tangent of theta. And then we get inverse tangent of that of y over x to get our theta, which is our angle. And to get our actual angle, we had to minus this angle by 90. So 90 minus tangent, inverse tangent of y over x. So let's just do this on our calculator. So we have 420 times sine of 50 minus 20 times sine of 70 divided by 420 cosine of 50 plus 20 times cosine of 70. And then inverse tangent that amount, and then 90 minus that. And we should have an angle of 24.42 degrees to the nearest hundredths. And that's your answer for number 20. So you just need to set it up. Well, that basically covers number 17 and 20. Thanks for watching, and I'll see you at the next math record.